Hello. So today's problem is there is a binary grid given. That means the values inside the grid is uh, 0 or 1 and it's of n cross n size. Our target will be to make sure that the final grid will have, so this is the diagonal. So our target will be the final grid, any grid above the diagonal will have only zeros, right? So for this we are allowed to do swap of rows, but there is a catch that only adjacent rows can be swapped. That means swap of I comma I plus 1 is only possible, not like I comma I plus 2. No, and we have to do minimum number of swap to get this result. So let's start with an example. So let's take the example number 1. So it's given 0 0 1 1 1 0 1 0 0, right? So here say this is the column number 0 1 2 and this is a row number 0 1 2. In the final grid, what is our target will be, as these are the diagonal, so this value should be 0, this value should be 0, this value should be 0. For this we have to do minimum swap. So let's think this from a different perspective, that for say row number 0, our target will be that anyhow for row 0 our target will be at anyhow we have to make sure there will be 2 zeros at end, right? You can see for row number 1, row 1, our target will be anyhow to get 1 zeros at end. You can see for row 2, 0 zeros at end. So is it possible to get 2 zeros at the end? Yes, we can see that there is a row which have 2 zeros at the end. At the end means from right to left we will have at least 2 zeros. This is at least. So this is at least. For row 1, yes, we can see there is a row which have at least 1 zeros from right to left, and for this one no zeros required. So to solve this we have got the intuition that we have to make sure that we need to store the count of number of zeros from right to left, right? So using that what we can do is that, say somehow we have got this value. Next we have to traverse for each and every row. Traverse for say this row. Let's take the same example again. 0 0 1 1 0 1 0 0, right? And number of zeros from right to left, say this is row number 0 1 2. For this one right to left it's 1 only, so it will be 0. Then for row number 1 it's 1 1. For row number 2 it's 2, right? What this vector represent is number of 0 from right to left. Now we have got this vector, say 0 1 2. This represents the row index and this is the number of zeros from right to left. Now we have to traverse this, right? Traverse this vector. Say you are at here. What was your target for row 0? For row 0, our target was at least 2 zeros at the end. So for row 0, you are at row 0. Row 0 target is greater than equals to 2 zeros. So traverse using another loop, check whether it is possible to do the same or not. Is it possible? No. Then go to this index. Is it possible? Yes. So you have to swap. So after swapping, what it will look like? The swap will be adjacent, right? So after swapping, the vector will look like 0, 2, 1. Then another swap, it will be 2, 0, 1, right? So total number of swap was 2. Then again for this index, this is done for this index. Number of for say row 1, right? This is row 0, row 1, row 2. Our target was greater than equals to 1 zeros, right? Is it possible? Let's check for other indexes. Is it possible? Yes. So we need to do a swap of one time. So final vector will look like 0, and our swap count got increased by 1. So yes, it is possible. So total number of swap required was +2 and +1, that is +3. Answer is +3. Let's try for another example that is 0, example 2, that is 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. Right? So let's make a vector, number of zeros right to left, and this is row 0, row 1, row 2, row 3. Row 0, 1, 2, 3. This is the vector. So for row 0 it is 1, for row 1 also it is 1, for row 2 also it is 1, for row 3 also it is 1. So our vector is 1, 1, 1, 1. So we have got this vector. So let's traverse this vector and check whether it is possible to get our target. What will be our target? Target will be for 4x4 matrix. This will be 0, 0, 0, 0, 0, and 0. This should be our target, right? So our target should be, this vector should look like 3. Here 3 zeros from right to left. Here 2, here 1, here 0. So let's traverse this. Is it possible to get a value of 3 greater? Is it possible to get a value greater than equals to 3 from any of its indexes at the right side? No. So just return -1 because it is not possible. So now another thing you might ask, what is the target? We were saying target, how to get the value of target. So the target will be in minus row -1. Okay, you can check from here also. Say for this row, say you are given this row value 0, 1, 2, row index 0 and 2 here. So for this one, the target will be 3 minus 0 minus 1, that means 2. For this one, it will be 3 minus 1 minus 1, that means 1. For this one, it will be 3 minus 2 minus 1, that will be 0. And you can verify from here only. So the here value should be 0. For this one, this value should be 0. So 2 1 0, right? Let's code it up. Before that, let's write the pseudocode. Value of int n equals to grid dot size, right? Then make a vector to store class zeros and make it of size n, right? Now your task is to traverse from right to left and get number of zeros at the end, right to left, for each row. How to do so? Just for each row, int I equals to 0, traverse each row, and you will get say initially your index is called C column, that is n minus 1, and use a while loop, while greater than equals to 0, and grid I and column is 0. Just do column minus minus, right? So using this, what will happen is that you will reach till a index where the value will be 1. That means before that all grid values will have 0. So using that, you will get the length. So the length will be, just put that length into this vector. So last zeros of I equals to n minus column minus 1. So this is the length. Now what you have to do is that you have to swap and check whether it is possible or not, and if swap, check whether possible or not, it will be adjacent swap, possible or not, and if possible, count. If possible, then count, increase the count. So take a variable count, and for traverse for each row, plus plus. So your target will be, in target, as mentioned here, your target will be n minus row minus 1. So target will be n minus row minus 1. Now check if target is lesser than equals to last zeros in this current index, last zeros in current index. That means no need to swap. So just do continue. Otherwise there is a swap required. So say int I equals to row plus 1. So say this is at the row, you are currently at this row. So from this row till this row, you have to traverse and check for which row you are getting the value, and you have to just swap, right? So say this is the current I, this is the row. Now while I less than n and last zeros of I is lesser than target, you have to just do I plus plus. Say you reached here, so also check whether it is possible or not. Say you reach at this position, that means if I equals to R, means there is no way you can swap to make the current target fulfill. So just return -1. you can fulfill the current value. Otherwise, just swap. For I greater than row, just swap adjacent one. Swap last 0 of I and zeros of I minus 1. Increase the count also and just reduce I. So say you are here, so swap and your I will be here. Again swap, your I will be here. Again swap, your I will be here. Again swap, your I will be here. That's all. And you have to increase the count. And finally return count. Let's solve this question. First, let's get the size of the grid. Then we have to make a temporary vector and say last zeros of size n. What it will store? It will store number of 0 from right to left for each row. Right? Now we have to update this vector, right? Calculate zeros at each row, right to left, right? So say for int row equals to 0, row minus row and row plus column and while 0 while column and create of you have to just column minus and finally update last zeros of row equals to n minus. Just update this value with the length. The length will be n minus the column index minus 1, right? And then you have to swap and you have to check whether is it possible or not. If yes, swap and count plus, right? So make a variable count and traverse for each row. For int row equals to 0, row less. So here your target or required will be n minus row minus 1, as we have mentioned in earlier. Now if your target is less than equals to already available number of zeros for current row, that means no swap required. Otherwise there is a requirement for swap. Then check the best index possible. So check means best. So for this make temporary index I equals to row plus 1 from next row using a while loop. Say I while I less than n and last zeros of I is less than target, just do I plus plus. Now if your I has crossed the boundary, not possible. So for not possible, they said just return minus 1. If I equals to n, just return minus 1. Otherwise swap adjacent means while I less than I greater than row, swap zeros of I and last zeros of I minus 1. Swap this and then count plus plus and I minus 1. Just return count. Let's check. Yeah, so let's submit. Okay, perfect.